Okay, we are going to do some more boards go up, please, today. Um, we're going to focus on integration questions, AP multiple choice questions. All these are publicly available from like old tests and stuff like that. Um, let me talk about my numbering system before we do any problems. The way that I got this number got generated, and I can't get rid of it. So I just wrote question one, and if you go down, they've all got those questions written out that I typed in there. So I'd like you to use that for the numbering system, not the other numbers that are there for each of these problems. Same deal as usual. I will show you the problem, maybe give you a little hint, and then tell you to press pause. After I tell you to press pause, you should go do it, and then check your answer with me afterwards. Um, I'm gonna have you hand this in, so please make sure that you're doing these. You don't have to like write everything out. You can write your scratch work out for each problem. That's totally fine. It would be a lot of work to write everything out. I just want you to write your scratch work, what you're doing to be able to solve this problem, and then what your answer is. Um, with just about all these, it'd be pretty impossible to just like come up with an answer. So maybe some of them if you're really quick with the use of, but I do want you to show some work, not just write, oh, I got letter C. Cool. Everyone understand the rules? I hope so. Thumbsies? Thumbs up? Yeah? Okay, cool. I thumbed my, I, I stuck my thumbs up. I hope you did too. All right. We're all going crazy here, aren't we? Here we go. Let's go. First one. Integral 1 to 10 is 4. Integral 10 to 3 is 7. What is the integral from 1 to 3? Be careful of this order of integration right here. Go ahead, press pause. And your answer's coming. So hopefully you pressed pause and tried it. Boom. I got E. Um, Here's my work. I'm using shorthand notation because it's a multiple choice question, right? I should probably write F in there if I was on an FRQ. But I look at all these bounds, right? And I say to myself, well, I know that the integral from 1 to 3, because it's area, plus the area from 1 to 10, or sorry, 3 to 10, is the integral from 1 to 10. So I look at what I have up here. I have the 1 to 10 right there. That's this. I have the 1 to 3. That's what I'm looking for. I need to turn this into 10 to 3. How do I do that? I flip it. And you should know that when we flip the bounds of integration, we negate that integral, right? So what I get is that integral from 1 to 3 minus 7, because this is a plus 7, is equal to, this guy is 4. Add the 7, it's just a simple equation now. 4 plus 7 gives me 11. Answer is E. All right, question 2. I will give you a hint before I tell you to pause with this one. They want us to find this integral for this thing right here. My suggestion is use your Algebra 1 skills, hopefully you still have them, to draw this piecewise function. So draw it, and then calculate the area by doing rectangles and triangles. So you can hit pause now, give that a shot. Here comes your answer. Boom. Um, when I draw that, I get x minus 1. So I kind of like drew out a rectangular grid as well as I could. What did I start with? I drew the 2. Actually, I drew the 3 first. I drew this x value on the 3. And then I came over. I knew that was my spot where it would transition from one to the other. And then I drew the flat part, to the left of it, right? And then I drew this x minus 1. You can see my dotted line right there, hopefully. Hopefully it's showing up on YouTube. That dotted line right there would be x minus 1. It's got a slope of 1, and this y-intercept, a negative 1 right there. It goes dot, 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 up to here, where that would be at 3. I can see that because it's a nice square axis. And then it goes up like that. And I did my 1 and my 5 so that why did I do the 1 and the 5? Because those are the bouncy integral. Because I don't care about anything else outside those zones. So from there, I looked at this rectangle right here. That rectangle was 2 tall and 4 wide, so 2 times 4 was 8. And then this rectangle right here, base of 2, height of 2, or sorry, rectangle, triangle, 1/2 base times height gives me 2. Take the 8 and the 2, add them, get the 10. My answer is D. All right, let's do question 3 here. This one is similar to the last one. There's one thing that they're trying to trip you up with here, and that is this piece right here, cosine of pi. Well, there's no x in there, so all you got to do is figure out what the cosine of pi is, and then it's a constant, like it's flat, kind of like, well, the 2 up here. Anyway, give this one a shot. I'm gonna flip over to my answer. Here we go. So, so first off, I did this several times. This is an AP question. I checked and they told me the answer was D, and I don't agree. I think it's B. So if you think it's D and you can convince me, then maybe you're right. But um, look, so I am doing the integral from -1 to 1 of this thing. I drew x plus 1. That's this guy. It's got a y-intercept of 1 and a slope of 1. It transitions at 0 to cosine of pi. Cosine of pi, well, pi is over here, so it's -1 there. So cosine is -1. So that means that from 0 on, it goes below the axis down there at 1, right? So what's the area of this thing? It's a positive half. What's the area of this thing? It's a -1. So when I do the when I add those two areas, I get a half minus 1, which gives me a -1/2, which is B. Hopefully you agree with me. I think I'm right. Should be right. Checked everything else. Did everything else correctly, at least. All the other problems, I mean. All right, so question number 4. So this one is like the other ones that we've seen, except for they give us the equation right here. So notice we have 3 options, or we have a fifth option down here, E8, right? So I'm going to scroll up so you can see the whole thing. We want to do the integral from -1 to 4 of this thing. So notice, whoop, that's the whole thing. So hit pause, do it. This one should be a gimme for you guys, I hope. Okay, here we go. Answer is B. What did I do to get B? I looked at this block right here that had an area of 2. This one had an area of 1 and another 1. So I got 1 plus 2 plus 1. These guys are below the axis. That's a -1/2 right there. This is a negative full 1 by 1 block. So I get 1 plus 2 plus 1 minus a half, that little triangle, minus 1, the square. These are -1/2. This is 4. 4 minus 1/2 gives me 2/2. So the answer is B. Next one. This one, they want me to, they tell me that G is the integral from -2 to x, right? So -2 is here, right? Of f of t dt, right? And they ask me which of the following values is the greatest. You could find all of these, or you could think through it and like what would be the greatest for this. All right, flipping. Oh, sorry. Let me give you all the options. Flipping to the answer. I got D, G of 1. And this is, my work isn't actually perfect. I start that integral at -2, so this is positive area here, right? This is negative area. So when I do the integral forwards for a number bigger than 2 here, I'm going to get a positive number minus this number. This area up here is clearly bigger than this. So the area function, which is what that g is, will be biggest at 1 there. Question is, what happens when we go backwards? Well, this is above the axis, so when we go backwards, we get a negative number. So Since this positive chunk right here is the biggest positive chunk, the max area will happen when we switch from positive area to negative area, so g of 1d. You could also use second FTC if you wanted here, but the answer is D, g of 1. Next one. All right, I'm going to give you a little hint with this one because there's an easy way and a complicated way. The complicated way would be to use u sub. The easy way is to FOIL this thing, right? You know how to FOIL. And then integrate individually using power rule. It's definite integral, so make sure you get those bounds. All right, go ahead, pause and do it. All right, let's go to the answer. I got D, 1. All right, so when I FOIL this thing, I write 2 of them, and then I multiply, right? This times this gives me 9x squared. And then I get the first term is minus 6x, the next term is minus 6x, and I get a plus 4. So really this right here is 9x squared minus 12x plus 4, and that's what I want to integrate. When I integrate that, some power rule, this goes to 3x cubed, this goes to 6x squared, this guy goes to 4x, evaluated from 0 to 1. Now, what's nice when I have these polynomials, if I'm evaluating from 0 to 1, you see that each of these, the second half of the evaluation of the integral, each of these is going to evaluate to 0 all there. Well, when I plug in 1, what's 1 cubed? 1. What's 1 squared? 1. What's 1? It's 1. So it really just gives me the 3, all those coefficients with the correct signs. To get 3 minus 6 plus 4, and then I subtract 0, and that gives me 1. So D. Hopefully you're good with that. Next question, question 7. All right, so I want to do the integral from 0 to x of sine of t dt. Look at all these answers. All of them have x's in it, right? So you're going to integrate that and evaluate that and subtract appropriately. So hit pause, give it your best shot. Here comes the answer. All right, so I got E. I got negative. Careful with that integration. That's probably I bet the most common incorrect answer for this one is D, or maybe C if you mess up your trig. But what you got to do here is integrate. What would derive to sine? Well, it would be a cosine. But remember, cosine derives to a negative sign, so I need this negative here to balance that out. Evaluate between these two. So I get negative cosine x minus a negative cosine of 0. Well, there's a double negative there, so it's a plus. So I get negative cosine x plus cosine of 0. Well, that's not here. I need to evaluate that cosine of 0. You should be able to do that. So I put a dot on the unit circle at 0. Remember, cosine is the x-coordinate, goes alphabetically. It's the x-coordinate there. It's 1. So I get minus cosine x plus 1, which is E. So the answer is E. I'm going to stop this video here and pick it up in the next, pick up the next problem on the next video. So I will see you in a moment.